Hi, my name is Ivan. Mass, the basic concept in physics and quantity inherent in all materia in the universe. When we want to measure mass, we use scales, but they actually measure not mass, but weight. Weight is the force with which one object acts on another object. Physicists rarely talk about weight because it is determined by mass, and some objects actually have no weight at all. For example, the Sun is a very massive but absolutely weightless object. Mass of the Sun, as the mass of everything around us, is the sum of the masses of all its atoms, which consist of protons, neutrons and electrons. There are many other particles and they all have their own masses, except for two: photon, particle of light, and gluon, which as glue binds quarks inside of protons and neutrons. So where do particles get mass from? They get it from the Higgs field. If other fields, for example electromagnetic, unevenly affect the surrounding world, the Higgs field equally affects every particle in the universe. This means that the mass of any particle is constant everywhere. Without the Higgs field, particles would be free to fly through the universe with near light speed. The Higgs field, as water, does not allow them to move so easily, but if the water simply prevents any movement of the objects, then the Higgs field only prevents particle acceleration but not their uniform motion. It's like particles sink in the Higgs field. Each particle sinks in its own way, and stronger it does, the greater mass it has. The discovery of Higgs mechanism was a real breakthrough in quantum physics. But it works only with elementary particles. What about composite protons and neutrons? They get their mass in a different way. It would seem that if they consist of quarks and massless gluons, then by adding masses of quarks, you get the mass of proton and neutron, actually only 9% of their masses. To understand why, let's look inside. Usually, quarks are depicted as three balls sitting quietly inside. But in fact, in proton and neutron there are many other quarks and antiquarks that appear and disappear, move at near light speeds, and gluons create a field that does not allow quarks to scatter. In all these processes, a large amount of energy is involved. Thanks for the most famous formula E equals mc squared, where E is the energy inside a proton and neutron, and specifically the energy of the gluon field and the energy of motion of quarks. M is the mass of proton and neutron, including the mass of quarks, and c is the speed of light. We can find mass of proton and neutron. This equation shows that energy and mass are of the same nature. The discovery that mass and energy are actually of the same nature was one of the greatest breakthroughs in the history of physics. But still, science has many other questions about origin of the mass. Perhaps answers to these questions can be your breakthroughs. Thank you for watching.